Hi everyone, in this video we're going to have a look at a bit of a review of probability and in particular how to calculate different probabilities. Now there are two different types that we're going to look at. There is theoretical probability and experimental probability. So theoretical probability is just where you calculate probabilities based on what you know about a situation. So for example, you know that a coin only has two sides. So using that knowledge, you would calculate a probability of something happening. We know that a dice only has 6 sides, and we know that the chance of each happening is equal. So theoretical probability is where you calculate a probability or an event happening based on what you know. That's the theory part of theoretical, to make that calculation. Whereas experimental probability, it's where you conduct an experiment. So you actually test. So you actually flip a coin a few times, you actually roll that dice a few times to see what actually happens. And we'll have a look at a couple of examples right now. Now the good news is that the formula for both is pretty much the same, but let's have a look at experimental probability first. Let's pretend that we roll a dice and the first time we get a 1. The second time we get a 3, then a 3, then a 1, then a 4, a 5, a 2, and a 6. Now you can see straight away that not every number on our dice has been rolled, but because this is an experiment, we're testing to see what actually happens. So if we wanted to find the probability of rolling a 6, well, we would use this formula up the top. So on the top of our fraction, we need to know, well, how many favourable outcomes happened, or how many outcomes happened that we like. So in total, there was only 1 6. And then on the bottom of the fraction, we need the total number of trials. So we did 1, 2, 3, 4, 5, 6, 7, 8. We did 8 trials. Oh, that's not an 8. This is an 8. So the probability of rolling a 6 was 1/8. Now, if we wanted to see this probability as a decimal, we would have 0.125. If we wanted to see this as a percentage, well, then we'd have to times that by 100, and it is 12.5%. Let's have a look at another one. So if we want to see the probability that we get an even number, well, we have to look at how many favourable outcomes do we have. So we've got 1, 2, 3. So that's 3 favourable outcomes, or 3 outcomes that we like. And then on the bottom, how many trials in total? So there's still 8. So 3 out of 8. And if we wanted to see this as a decimal, we would get our calculator and type in 3 divided by 8, and we would get 0.375. And if we wanted this as a percentage, we'd have to times that one by 100. So that's equivalent of 37.5%. Let's have a look at one more quick example. So this time it's about different cars and their colour. So I stood out the front of school and I recorded down the colours of cars that went past in 1 minute. And I recorded there were 2 blue, 1 red car, 3 green cars, and 2 black cars. So if I was to use this experiment to help me calculate the probability that a car I pick at random might be one of these colours, this is how I would do it. So I've got all of my trials up here. So if I wanted to find out, well, what's the probability that a car might be blue based on this experiment? There are 2 favourable outcomes, that's these 2 here, out of a total of 1, 2, 3, 4, 5, 6, 7, 8, total of 8. So 2 out of 8, and I can simplify that fraction to be 1 out of 4. Now, if I wanted to work out what is the probability that a car might be red, well, there is only 1 favourable outcome out of a total of 8, because there's only 1 red car that was part of the experiment, only 1 trial came out as red. And lastly, if I wanted to find what is the probability that a car might be green or black, well, 1, 2, 3, 4, 5 cars fit this, or 5 of the trials, so 5 favourable outcomes out of a total of 8. Now, with theoretical probability, this time we don't have trials to use. We have to use what we know about this situation. So let's look at 3 different examples: flipping a coin, rolling a dice or maybe using playing cards. So first, let's have a look at the probability that with a coin, we flip it and it comes out as a head. So we know that there are a total number of 2 different possibilities that you can get when you flip a regular coin, a head or a tail. And out of those 2 things, only one of them is the one that we like, only one of them is a head. So it's 1 out of 2. What about the probability that it's a tail? Well, if you flip a coin, there are 2 possible outcomes, and there is only one that we like here. Only one of those outcomes is a tail. What about the probability that we get a head or a tail? Well, there are 2 possible outcomes when you flip a coin, and out of those 2 outcomes, both of them are favourable. Both of them are the outcomes that we like. So it's 2 out of 2, or really, it's a whole. Now, if we were to think about a dice, sometimes it's handy to write out the sample space. So the sample space of a dice is this. So let's have a look. What is the probability of rolling a 3? Well, the total number of outcomes at the bottom of the fraction, there are 6 different outcomes that I could get, but only one of them is favourable, only one of them is a 3. What about the probability of an odd number? Well, total number of outcomes is still 6, and the odd outcomes, 1, 2, 3, there's 3 of them, so it's 3 out of 6, and I can simplify this one to 2 out of 3. Now, playing cards. Now let's think about the different suits that you can get in playing cards. So it's handy to write out the sample space. So you can have diamonds, you can have hearts, you can have spades, and you can have clubs. Now, excuse my bad drawing, but I think it's something like this. Oh yeah, that's not too bad. So they're the different types of cards or suits of cards that you could get. So what's the probability that you would get a diamond? Well, there are 4 different possible outcomes, and only one of them is favourable. Only one of these is a diamond type. What about the probability that we would get a heart? Well, there are still 4 possible outcomes, and only one of those is a heart. Now, what happens if we think about something different? Maybe the colour of these cards. So a diamond is red, a heart is also red. Clubs and spades are both black. Let's have a look at something like this. So what's the probability that I would get a red playing card? Well, there are 4 possible outcomes, and 2 of them are red. So it's 2 out of 4, and I can simplify that one to 1 out of 2.